Thank you very much. And although the tag here says that I'm from an office in Mexico, I'm actually from an office in Knoxville, Tennessee. And Henrique is from our Houston office. And we're glad to be here. I've spent the last 2 days practicing my understanding of Spanish, and now I'm going to use English to try to communicate to you. Okay? I do have one question for you first, sir. Who is Henry Hub, and why does he have all the gas?
Henry Hub is Henry Hub.
Yeah. It's a place. It's a location that we use for a baseline price, but I've had people ask, who is Henry Hub?
It's Henry.
Yeah. Henrique and I were talking last night, and we've worked together for a little more than 30 years. And when he came to the United States, he came to the same school that I had gone to, and he got a PhD in a language that wasn't his native language, in a discipline that wasn't his bachelor's engineering discipline. And so I knew then he was pretty smart, and I was going to work for him for some time. Okay? So I'm working for him now. That's why I'm presenting and he's sitting here. Okay? I do want to do a little audience participation because I think some of you are just barely awake. Okay? So I want to know, and over the course of this talk, I'm going to be talking about different groups of people and what their roles are in codes and standards in the LNG business. Okay, I'm going to talk nicely about everybody, so you can admit that you're one of these people. Do we have any people that are regulators? You work for a government organization that regulates the energy industry. You got any of those folks? Come on. Okay. All right. There's some out there. Anybody who works in supplying floating storage and regasification units, FSRUs, okay, the accelerates, those kind of folks, okay. I'm still going to talk nice about them, even though they're not here. Tractebel Suez, engineering company that does a lot of engineering on facilities, because I've been involved with them in a Chilean project. Petrobras, okay. Worked on 3 projects with Petrobras. We'll talk about Gas Atacama out of Chile. Okay, you've worked with them, okay, and Gas Sayago, okay. So there's not a lot of the people there that I've worked with, so I get to tell you anything I want to, and there's nobody to argue with me. Just an outline. We're going to talk about, it's not a sales pitch, but I will talk a little bit about the LNG experience that I'm using for the basis for this paper. We're talking about historically what's been used in the LNG business, and codes and standards are changing. The codes that have been out there are changing, and new codes are coming on. Okay, wanted to talk about the trends and the facilities we've seen in Latin America, and what issues we've had in developing those facilities, and what that means for the future, and give you some approaches for addressing some of those issues. There we go. You saw this slide yesterday in Mario's presentation, and my only point is that right down here is where my business is. It's safety, risk, integrity management services. We basically help people satisfy regulations, operate facilities safely. Okay, it's a good thing when my clients don't have an explosion, don't have a fire. People are safe and they go home the next day. That's what we're looking for. If you look at the work that I've done in the LNG and the company has done in LNG over the years, a lot of work for the U.S. Coast Guard, okay? The maritime regulator. I'll talk about the regulatory landscape in the U.S., and it's different down here, okay? But we've done a lot of work for the U.S. Coast Guard. One of the things the Coast Guard requires a developer to do is a waterway suitability assessment. Is this location for a terminal appropriate in terms of bringing an LNG carrier in, because they were historically they were import facilities. You were bringing a carrier in full of LNG. It had to share the waterway with other users. It had to safely navigate and had to be able to be docked at a facility to unload, okay? Then after unloading, it had to go back out, okay? For some ports, that's quite easy. There's a short approach from the ocean to the pier, that you're the jetty that you're going to unload. In other cases, it may be 15 or 20 miles up a river. Okay, so a suitability assessment has a safety and a security assessment in it. It talks about the impact on the port. In the U.S., when you're licensing an LNG facility, you don't have the ability to shut down all the other port activities that go on. You have to reside there as a good neighbor. Okay, the fishermen still want to fish. The recreational boaters still want to violate all the rules. I mean, they still want to use their boats. Okay, the other cargo shipments come and go. Okay, so the suitability assessment brings all that together to say, is this an appropriate use of the waterway? Since 2001 with the IMO, International Ship and Port Security Code, we've done security assessments both to the IMO standard and in the U.S. to Coast Guard standards. People have asked us to look at facility siting, not only from the maritime perspective, but from the seismic, from the utility, the infrastructure, the other kinds of issues where we've done siting and risk assessments. Once facilities are being built, our folks will do construction verification, quality services, those type things, and compliance certifications, that someone's meeting a regulation or meeting some other contractual requirement. Okay. When I talk historical, my focus here is primarily in the U.S., and then I'm not going to address the Japanese standards, and the Japanese have huge amounts of LNG experience, obviously. I am going to talk to some extent about the European norm and some of the standards coming out of there, because they really offer some advantages over maybe the U.S. standards. In the U.S., you have to have an approval by the Federal Energy Regulatory Commission. They're the people that license an LNG facility that's going to import or export. They do that, they're an independent agency. They do that under the Department of Transportation regulations. Department of Transportation, because import and export facilities of any size at all are going to connect to pipelines. And pipelines are DOT, Department of Transportation regulated. So there are U.S. codes of federal regulations from the Coast Guard and from DOT that are specific to LNG. Okay? When I got started in Latin America, that wasn't the case. Increasingly, that is the case, that there are being some specific national regulations. And that helps when they're good ones. Okay? And when I say good ones, I don't like some of what's in the American regulations either, okay? There's also requirements to file environmental impact reports, EIRs or EISs, environmental impact statements. And there are Coast Guard or Navy maritime rules in terms of what you have to do before you can bring LNG into a port. Traditionally, one of the very important standards has been the National Fire Protection Association. That's NFPA, National Fire Protection Standard 59A. This applies to onshore facilities for production, storage, and handling of LNG. And it came out originally, I had a note here someplace, 1969, I think, was the first approval, and it's been revised 10 times, okay? And I have other slides about it. It has some positive things and some very negative things. Around the world, if people don't have their own regulation, they'll often ask that you meet NFPA 59A. Now, the European norm 1473 is a standard that started as a British standard, okay, a BS standard you'll find, and became a European norm. Again, very similar to 59A in that it only applies to onshore facilities. If you go back in 2007 and 8, when people were starting to do floating facilities, they were still referencing these codes, but they clearly don't apply. So people would say, meet 59A or meet the European norm, but there are things in there that don't work when you're floating on the water. So you had to negotiate with the regulator where you said meet it, but what parts of it apply? How do we apply it? So if I go to a slide here on 59A, issued in 67, and the current version is a 2013, which means if you started a facility 2 years ago, they probably referenced the before 2013, there was a 2009 version, I believe, okay? But if you look in the US regulations, the regulations refer to the 1996 version, so you have to go, what do I need to meet, okay? So you got to get the right standard, you got to understand it. And it's not necessarily a simple thing. I printed this double-sided. I'm not going to read it to you. It's 2 columns, about 80 pages, and it's complex. It really is. I mean, you read this and it references another part and you have to go read that and come back and read the first part. It's, you know, it's a consensus standard. It's written by a committee, okay? And you know what they say about committees, you know? A camel is a horse that was designed by a committee. That's sometimes what you get, okay? It's what I would call a specification standard. It tells you what to do. You shall make your tanks in accordance with this standard. You shall do this, okay? It's a traditional US type regulation as opposed to being performance-based, telling you what you have to accomplish but not how you have to do it. Another thing that bothers me personally, they don't really ask my opinion, but it doesn't really impose an overall safety management system. You can build the best hardware in the world, you can have the right pressure vessels, the right storage tanks, the right piping, valves, and instrumentation. If you don't manage it properly, it's not going to work appropriately over the course of 10, 20 to 40 years. In the US, overall hazardous materials have to meet a process safety management standard, okay? But because these facilities, LNG facilities, are regulated by a different agency, LNG facilities don't have to meet the safety management standard. Now, in this standard, it does have, you have to have safety, security, you have to have operations, maintenance, training, there's, you know, competency requirements for designers and fabricators. So those are elements of safety management. But for example, a very important part of any program that we look at an LNG facility is how do you manage change? The designer designs it, the constructor builds it, and then someone goes to operate it, and in a year you find you have a problem and you need to make a change. Well, how do you make a change that doesn't cause things to be worse? They may solve the problem that you're worried about, but in 5 years later they may cause a different problem. So that's the kind of aspect that I think clearly needs to be in a program, but that the code and standard doesn't require. The most famous thing in 59A is that it requires exclusion zones, okay? Exclusion zones look at certain scenarios and say, if this happens and LNG is released, the flammable distance that is reached, there are limits on how far a flammable concentration or 50% of the flammable concentration reaches. There's a requirement that if there's a fire involving an impounding area, if you spill LNG, you have to have an area where it gets collected. A fire over an impoundment area can expose occupied locations to greater than a certain radiant heat flux, okay? So those are, they're not really risk, they're only consequence standards. You have to meet that or your site is not acceptable, okay? And over the years, people have said, those are really pretty arbitrary standards. Like one of the requirements is, I've gone out and I've built full containment tanks. I've got metal tanks inside a pre-stressed concrete tank with a pre-stressed concrete roof. And there's a requirement in the standard that you assume there's a tank fire and that the tank is burning from the top. I don't know what happened to the roof. Nobody ever told me what happened to the roof, but it's gone, okay? And so you assume now this tank is burning from the top, and the requirement is it doesn't cause too high a temperature on other tanks. So this tank fire doesn't cause that tank to fail. You know, if you can pass that test, if you have the real estate to put them far enough apart, that's an okay thing, but do I really think that I'm worried about somebody stealing the roof to my tank and setting it on fire? Not really, okay? Now, because of pressure from the industry and input from how the Europeans do it, there is a performance-based alternative in this standard. In 2009, or in the previous version, I think it was 2009, it was an option. It was not a mandatory thing, and it was in an appendix. Now it's moved into Chapter 15, and it is a alternative that you can choose to select, okay? Now, for this code and standard, the way it's written is everything you do in deciding how you're going to meet the standard has to be approved by the authority having jurisdiction, okay? In the US, that will mean state fire marshal, local fire department chief, planning, codes and standards, somebody in the municipal and state type level, okay? In the US, first you have to satisfy the federal agencies, and then you have to satisfy state and local. So you'll hear people now talk about a Chapter 15 analysis, which is a risk assessment approach. Instead of meeting the specification approach, you can say, I'm going to show that this is acceptably safe, okay? You don't prove things are safe. You don't prove things are no risk. You just are trying to show that they're appropriately safe. And there are standards that you hold yourself to in doing that. The place I'm seeing Chapter 15 analyses being used is interesting because we're now beginning to see export facilities proposed. Your picture with the 20 export facilities, that number may be low now, but that's interesting because that picture used to be 20 to 40 import facilities, and now a lot of them are going to be exports. And some of the new export facilities in the US are floating liquefaction facilities, okay? So they're going to fabricate a ship with tanks in it. On the deck, you're going to have liquefaction equipment, okay? You're going to bring it into a pier in Louisiana or Texas or someplace else, and you're going to produce off of the natural gas pipeline. You're going to liquefy, put it in the tanks of this floating vessel. Another vessel will come and pick it up, and that'll be export. And so in that, if you can picture that ship with tanks below the deck and process on top of the tank, now you've got the 59A requirement to assume that a tank is on fire and does it cause impacts on the other tanks. Again, it's not a reasonable scenario for that kind of a vessel. It's not a reasonable scenario for an onshore facility either, but it's caused a lot of problems for the export people. So they are going to be using Chapter 15 analyses to address that. Let's set that there. So in working, my experience was within FPA 59A, and in working here in Latin America, with the Petrobras series of FSRUs, I'll show you later, I didn't really see 1473 that much. But when we worked in Chile on the Miones terminal, that was Tractebel Suez was the architect, engineering, constructor, and obviously they have huge experience with the European norm, okay? Approved as a British standard in '97, and it is much more performance-based, where the American standard says you shall do this. The European norm says you must consider these factors when you do this. Okay, you must, get an approved siting, and approved siting you should consider these factors, okay? And it has risk analysis built into it. It requires a quality management system, and it requires a safety management system, and those are topics near and dear to my heart because I think they're very, very important. The hazard assessment, it can be either probabilistic, it can be quantitative or qualitative. They call it probabilistic, and their words are different, but to me it's a quantitative or a qualitative approach. Okay, and so now we've moved to a standard that's 130 pages long. Okay, again, very complex, not really as hard to use as the US standard, but still there's a lot of familiarity you have to have, a lot of experience. A lot of times you need to look up and make sure you're doing the proper thing. So there's another one. The techniques in the qualitative side, you can do hazard and operability analysis, failure modes and effects analysis, event trees, and fault trees as you get into the quantitative aspects. All right? And, you know, there are lots of places that have produced guidelines for these types of standards. The Center for Chemical Process Safety is one of the places that you can get really good descriptions of how these kind of techniques are used. All right? As we moved on in 2012 to work with Gasayago in Montevideo, you started seeing this standard that was issued in late 2010, okay? And this is an ISO on the ship-to-shore interface. Things that the ship, the terminal, and the people in the port that provide services like tug, escort and docking tugs, people that provide stores, people that provide bunkering, those kind of things, have to do for safe transit of an LNG carrier. This standard is really very similar to what you see in the SIGTO guidelines, okay? On the next page, I'll show you some of the SIGTO is the Society for International Gas Terminal and Tanker Operators, okay? So it's the industry getting together and saying, hey, if we don't do this safely, we're going to get run out of business. We have a huge stake in not having LNG accidents. LNG in some parts of the world, like much of the United States, has a very, very terrible reputation as being high risk, although we have 50 years of experience saying it's really not a very high risk industry when you do it well. And the SIGTO recommendations are people saying, we don't want you in the business if you're not going to do it this well, okay? And this ISO standard looks a lot like their recommendations. It talks about the appropriate place to locate a terminal, what kind of conditions you should establish for minimum weather conditions or maximum winds, minimum visibility, those kind of things when you're going to enter a port. How many tugs you need to be able to bring a carrier in with different kinds of currents and winds and that kind of thing, all right? So there's another ISO standard, and there are a lot of this series of ISO standards are from the committee, the technical committee on equipment for the petroleum industry, ISO TC 67, okay? This draft in 2012 is a subcommittee that is chaired by Petrobras, and they're putting together a guideline for hybrid floating and offshore, okay? Because even through this one at the top, it really was thinking of a ship coming to a dock at the shore, okay? And so this standard at the bottom is the first one that's really specifically addressing what has primarily happened in Latin America, which are the use of FSRUs. Now here in Peru, obviously you have an onshore terminal, but that's the exception. Everything else, don't ever say everything. Most of the rest of them are all floating facilities.
Quick.
I'm right? And
We did it quick.
yes, they were flexible. Flexible production, yeah, really quick. Just for your information, if you go and look at the SIGTO website, they, again, very valuable documents. In doing consulting, one of the things I do is get familiar with these and help other people get familiar with them. Because you'll hear in a minute, the engineers know how to engineer, the operators know how to operate, but a lot of what developing an LNG terminal is educating people. It's educating the new regulator, okay? It's educating the new mayor of the town, the governor of the state, the fire department, the fishermen, all those kind of things. And standards like this that people can pick up and read and say, oh, that's how they do it. And that's how they've done it for 50 years. These help tremendously. Okay, So I've talked about a number of facilities. With Petrobras, we've worked on all three of the FSRUs in the north, in Pasang, then in Guanabara Bay, and in Bahia, All Saints Bay. All right. Again, these were needed in a hurry. There were changes in gas distribution in South America. They were worried about dry seasons, and so these were not necessarily going to be operating 100% of the time, but they wanted them very quickly, and they did that by doing floating storage and revaporization units. And an FSRU is basically these were mostly conversions of LNG tankers, where they've taken an LNG tanker and put the regasification on the deck. Okay, you then moor that someplace. At Pasang, it's moored in a cargo terminal at a berth by itself, and the carrier comes in across the dock from that, and you transfer from the carrier to the FSRU. The carrier goes away, the FSRU has its own storage, and it can vaporize into the natural gas pipeline. In Guanabara Bay, they built a jetty out in the middle of the bay. You come in, you wave at the great beaches, and you come up past downtown, and you go under the Niterói Bridge, and you're up in the upper reaches of the Guanabara Bay, and there's a dock where the FSRU is sitting there, and the LNG carrier parks again across the dock from it, unloads, and then it leaves. Bahia I'm not as familiar with. I worked on it slightly, but I haven't visited it. In Chile, Quintero is not one that we've worked on. It was built originally as an onshore, totally onshore facility. They built tanks. At Miones, they built the revaporization on shore, but they used a floating storage unit. This, instead of an FSRU, it was an FSU. Okay, the revaporization was on shore because the long lead time item were building the large tanks. All right. Bahia Blanca is not one we've worked on. That's a gas port type design, an accelerate design. I left off the list. One of my colleagues chastised me for leaving the other Argentinian. Escobar started in about 2010. Okay, another FSRU type arrangement. And obviously the facility here in Peru is an onshore. And in Uruguay, they just recently let a contract for the terminal in Montevideo. Again, it's going to be out in the bay, not connected to the shore, okay? And Tractebel was just awarded the engineering and construction contract for that. So all of these were the first LNG operation for these energy companies in these countries. And so you had new regulators. You had national and state level regulators. In Brazil, you might have a national energy regulator, but a state environmental regulator. Maybe it's the other way around. But you have to educate the national folks one point, and then you have to educate the state people 3 different times because they're different places. And the regulators really are highly motivated. They want to do something that's good for the country. They're looking to make sure that what you're doing is safe. Okay, they feel that environmental responsibility that you have to meet. They want you to contribute to the economy. Okay, they want to not ruin their personal career approving something that somebody else decides is not acceptable. And then sometimes there's a little political pressure on regulators. Not in all cases, but we all have bosses, remember? And it really helped. Again, you're going to hear that education was a part of what we did. If you just think about the 3 projects in Brazil, all those projects had workshops where the project team members did work about the risks and the requirements and the standards. But we also had a half day that was a public meeting where we taught people about compressed natural gas and liquefied natural gas. Henrique taught a 1-day LNG class. I taught a 2-day LNG class. We taught a 2-week LNG class at Petrobras University, where beyond safety and security and equipment, we did the finances. We brought in PhD economists and did the finances of of LNG and contracting and all that. And that's part of what it takes. The new technologies, because these were really some of the first, if not the first, some of the first FSRUs in the world. There are FSRUs now in other locations, but these were some of the first. We used a lot of the classification society standards, okay, for offshore LNG terminals, but they were just being issued back in 2010, so those were new also. So we had the issues of limited regulatory experience. There was no long-term, here's how we've always approved those kinds of facilities. There was a tendency on the regulators' part to say, well, there's a good American standard and there's a good European standard, use them both. Well, sometimes they conflict, okay? They do things differently. Both of those are for onshore terminals. They don't really fit the FSRU. So if NFPA 59A is imposed on my floating facility, I have to go through it and say, okay, yes, sir, we're going to use 59A, and it has 400 requirements, and 312 of them are appropriate for floating facilities, and you've got to get them to agree to that, because what you don't want is to get it approved by the person who's currently there. You want them to agree to that in writing, you know, in your license, because you don't want the person who's there now to retire and the new person says, oh, there's another 42 things you need to comply with, okay? So the licensing and the documentation was very important. And there's the fear of the unknown. I have a couple of issues that people, I better wait for another slide or two. I look down at my slide and it says, don't talk about these issues here. You have more slides, Myron. Wait till later. Okay? So to address limited regulations, define your approach, make your commitments clear. Okay? And that was an important part of getting those projects. Educating people about what applies, if exact standards and regulatory and consensus standards don't apply, use the guidelines where you can. All right? Fear of the unknown and overstatement of the LNG risks. If people are overstating LNG risks, it doesn't help if the industry understates them. Because if you understate the risk, people just don't trust you. Here's an example that I've fought for years. Are you familiar with gasoline? Gasoline is a product, a liquid, okay? Does anybody want to say gasoline doesn't burn? Gasoline burns. You would think gasoline burns, right? Okay. I can go to the internet right now and go LNG does not burn, and you'll find lots of reputable organizations and people have presented papers and written things that says LNG does not burn. Well, we import it to the country to burn it, right? What they're saying is at minus 160 degrees, as a liquid, LNG doesn't burn. But that's not what people are concerned about. They're concerned about if I spill it out of this container onto the floor, it's going to start vaporizing. And very near the puddle, it's going to be too rich to burn. But someplace between there and the back of the room, it will go through the flammable range. And if it ignites then, you're going to have a fire. It's not the end of the world. It's probably going to be a slow fire. It's going to burn back, and then you're going to have this little pool fire here, or a great big pool fire, okay? So it's telling people it doesn't burn is true and a lie. It is true that liquid LNG doesn't burn, but LNG released in accidents can burn. And people just get mad when you try to wave science at them and disregard their concern. You need to accept people's concerns as valid, because they're valid to them even if they're based on something that's wrong. Even if they've listened to this idea that an LNG carrier has the energy equivalent of multiple nuclear weapons. You know, The problem is there's a lot of energy there, but the good news is that energy is released slowly as you burn this material. There is no way that that energy can be released, anything like a nuclear weapon, okay? So you have to explain things, you have to appreciate that people have bad information or they don't understand. Involving trusted partners. I'm a long-term believer in working on fixed facilities that one of the people that needs to understand what we're doing is the fire chief, the emergency responder. Because if that person understands, the rest of the community looks to them to help protect them. So if you can go to a public meeting and the fire chief is here and he goes, yes, we went to Texas A&M to the fire school, okay? And we learned how to deal with LNG fires, and they're really no different than other fires that we would deal with. And we are equipped to do it. We know how to do that. It doesn't matter what I say. The fire chief is a member of their community, and he's credible. I'm just a consultant. You're an energy company person. You're trying to sell hardware, None of you are reliable. The fire chief's reliable. In the maritime business, the equivalent, one of my favorite people is the maritime pilot. This is somebody who has the nerve to go out in a small boat and climb on to one of the biggest ships ever made and bring it into the port and put it at a dock. He's never been on that ship before, okay? He's dealing with a crew from some other country, and they have the confidence to do that. Well, going into these LNG studies, you have to get with those people and say, we want to help you. I've got a whole list of things we talk about with the Marine pilot. They need information. They want to know what's expected of them. We talk about what kind of vessels are you going to see? What kind of requirements are there? For example, these vessels are required to test their equipment before they enter the port. Other vessels don't necessarily have that kind of requirement. It's a good thing to do, but in the US and in other countries, people say, before you enter port, you've come across the ocean and you've been in forward. You haven't worried much about steering. You haven't put your engines in reverse. You haven't tested various systems. Test those systems before you come into our port, okay? So you do that. You convince them, thank you. You convince them that we're going to have requirements for weather. You won't be asked to bring one of these vessels in if there isn't a certain visibility. You won't be asked if the wind is too high. The vessel will have to stay off the coast until the conditions are right. Because normally a pilot gets all kinds of pressure. Oh, you can bring the ship in safely. You can, it's a cargo ship and we got to get this cargo off because it's got to go to the next port. With an LNG ship, typically you take that pressure off the pilot because the maritime authority, the Navy, the Coast Guard, whoever it is, says unless you've got a mile visibility, unless you've got this, okay, unless there are 2 tugs or 3 tugs or 4 tugs available, you can't bring the ship in. So once you've got that kind of communication with the pilot, he's then like the fire chief. He goes, oh, these are great ships. We went to, we typically would take them someplace and let them talk to other pilots that have done LNG carriers. They might take a trip on an LNG carrier. We'd take them to a bridge simulator and they'd work with piloting the ship with tugs. So all those things build confidence in them, and then you have that reliable, trusted partner. Because again, they don't trust you, they don't trust me, they trust that person in their community who plays a role in keeping them safe. Okay, I got just a couple minutes. Here's the most valuable thing you'll hear all day, okay? When we have public meetings, I learned this from a DuPont chemical plant manager. When he has public meetings, you people are here, you're concerned about what we're doing, you're concerned about safety. This plant manager would always have on the front row kids from the junior high or high school, 12, 15, 16 years old. They might be the science club, they might be the school newspaper. And he'd introduce them and said they're interested in learning what's going on in the community and about this technology. And so they'll be up here, and you should say hi to them sometime during the meeting. And what the plant manager told me and what I have seen is adults behave so much better when children are present. They may have concerns, they may not like what we're doing, but the level of shouting, the level of objection, it drops down because adults don't want to be seen as behaving badly when there are kids there. Mm-hmm. So I've done that now in some meetings, and so far it works for me as well. Whoops. So I guess what I'm saying is there are a lot of challenges in bringing LNG into new territories, using the codes and standards, using the 50 years of experience, the guidelines, and reaching out to stakeholders. In doing this, I never realized I was going to be talking to the fishermen, the city council, the state planning commission. All these kinds of people are all stakeholders in what you're trying to do, and talking to them and listening to them and addressing their concerns serves your purposes. So, thank you very much.